Hi guys, this is chapter 4, 4.1. My communication questions are 1 and 3 for my C by U. Let's get right into it. So, describe how the instantaneous rate of changes varies along a sin curve. Okay, so this is pretty easy. So, the IROC of a sin curve like y equals sin x is given by the derivative, which is dy over dx equals cos x. Okay, so derivative of sin equals cos x. Okay, that's derivative of sin. We got that. This tells us how steep the curve is at any point. At the peaks, maximum values, minimum of the curve, the IROC of change is 0. That means the curve is flat at those points. As you move from the peaks or values, the rate of change increases in magnitude, positive or negative. It goes positive or negative or down. Okay. All right. The the steepest slopes the steepest slope occurs halfway between a peak and a valley. That's when the curve is crossing the x-axis. At those points, the slope is positive or -1, the maximum steepness. Okay. The sign of the slope tells you direction. So positive slope equals curve is going upward right here. See, relates to that. Negative slope equals curve is going downwards. Like I said before, positive is going upwards for this, and for this it's going downwards. All right. So the rate of change, in short words, the rate of change varies continuously and periodically. It's just like the sin function itself. It oscillates between positive and negative, reaching 0 at local maximum and minimum. All right, let me just erase this real quick and we'll go to the next question. All right, so we have consider the curve y equals sin x on the domain x xcr and is between 0 and 2 pi. So how many local maximum are there? All right, we'll figure this out. So derivative of y, we already know is sin x, cos x, okay, equals cos x. So cos x equals 0. We have our unit circle. We'll put it short for UC. So this is cos and this is sin, okay? And this is 2 pi, pi over 2, pi, and 3 pi over 2. All right, so we need to find out where x equals 0. So pi over 2, let's make this straight, and 3 pi over 2, okay? So, give me a second. So derivative of cos. Now we're going to do second derivative test, okay? This is our first derivative, FD for F first derivative. Now we're going to do our second derivative test, okay? So derivative of cos x is what? That's negative sine x equals negative sine x. And then negative sine pi over 2 equals 1. And that would equal to -1, okay? Now we'll do the same thing for 3 pi over 2. Negative sine x. Here we have at 3 pi over 2, our value is -1. So negative sine, -1. Sorry, I meant +1 will be the answer, but I meant to say -1 when we substitute it, okay? So we have our values, okay? Now for the original, this is for the derivative. Now for the original equation, I'll show you guys the graph after because this question also says explain by graph. It's on my next slide. So now substitute it in our regular equation, okay? So y equals sin x. We already know y equals, we'll do pi over 2 equals sin, at pi over 2 we have 1. So this will be 1, okay? So y equals sin 3 pi over 2. We know at sin is -1, okay? -1. And this would be -1, okay? So how many local maximum are there? There will be, okay, so there will be 1 local maximum. I don't have enough space, so let me just erase this and put this right here, FD. So there is 1 local maximum, okay? 1. I'm not going to write local maximum, I'm going to put LM, capital. And is at its x equals pi over 2, where y equals 1. Just put this like this. Okay, how many local minimum are there? 1. On L, I'm gonna put M, short for minimum. And this is, it's my apostrophe right there. It's x equals 3 pi over 2, where y equals -1. Let's write it occurs. It occurs at x equals 3 pi over 2, where y equals -1, and we'll do it occurs here, but I don't have enough space, okay? So if we have our points for our regular function, we know our local maximum between 0, x and 2 pi, y equals 1, and local minimum between 0, x and 2 pi, y equals -1. Because at 3 pi over 2 and pi over 2 for our derivative, at pi over 2 is -1, at 3 pi over 2 is +1. Here, I'm going to explain this with a diagram. Give me 1 second. Okay, so here we could see our local maximum at 3 pi over 2. This is for our regular equation, okay? Y equals sin x. Let's not mind that. So right here, we could see our local minimum is at -1. And our local maximum is at +1. This is our cos x. See? It's just like that. Alright, thank you guys. Okay, so let's put our values. So at 3 pi over 2, comma, -1. At pi over 2, comma, let's see, 1 right here. That's a 1, that's a -1. Okay, we have our points. And you see for cos, it's local maximum still at 1, local minimum at pi over 2, -1. Remember the values we got there? And so this is for sine y equals sine x. And so the derivative which we got was at pi over 2 is -1. And why am I putting equal? I meant to put cos x. Let me just erase this real quick. dy x equals cos x. Alright, so our points here would be pi over 2, 1. Nope, it's -1 right here. See? -1. And our second point is 3 pi over 2. And that's going to be at +1. Just like how we got it in the second derivative, proving it is correct, okay? So pretty much that's it. The end. Thank you guys for watching. You guys enjoyed?